My name is Jeff Scott from Cornell Local Roads Program. I'm Technical Assistance Engineer. Today we're going to talk about erosion, ditches, and storm sewers. Well, I guess we'll start with trying to get this thing to work. All right, we'll start out with watersheds. The first thing we need to realize is we all live in a watershed. I've talked to people that say, I don't live in a watershed. And to me, that's kind of impossible. But anyway, New York State actually has 17 major watersheds. They all drain in different directions, whether it's the ocean or the river, or even over in the Housatonic over on the right. A lot of them go to the Great Lakes. You get the Mohawk River, St. Lawrence. So there's a variety of different locations where they drain to. This portion over here is the Allegheny watershed. That's actually the headwaters of the Mississippi. So we actually feed into the Gulf of Mexico as well as far as parts of New York State. But as I mentioned, we all live in a watershed, and precipitation is that lifeblood of that watershed. Without that water getting back into our soil and our aquifer, then everything fails at that point. So when rainfall lands on impervious surfaces or compacted soils, it tends to run off rapidly instead of percolating back into the ground. And ideally that's going to be one of the main things we're going to want to try to do, is get that moisture back into the ground and recharge those groundwater. A lot of times, because of that impervious surfaces and compact soils, we're going to get runoff that's going to contribute to flooding. And as it travels, it's going to collect up a lot of the pollutants that are going to degrade our water quality. Here's kind of a drawing here that illustrates kind of how the roadway ditches kind of collect and drain into the local streams within that watershed. There's hundreds of miles of ditches crisscross each watershed as we go through. While the ditches drain the roads, they also efficiently intercept a lot of the runoff from adjacent hills and some of the subsurface water that's within the soil that's already percolated into it. It can capture up to about 20% of the runoff in each of the watersheds. So basically what we're doing is collecting 20% of that water that's draining on the surface that hadn't had a chance to get back into the soil and repercolate that aquifer, is being picked up and channeled downstream. So again, in roadside ditches and storm sewers act as conduits for this water as well. And along the way, they pick up all kinds of road salts, fertilizers, pathogens, a variety of things. And we'll talk a little bit about that as we go through. So first, we'll talk about erosion. As anybody who ever seen pictures of the Grand Canyon knows that the erosion's been happening for a long time. It's nothing new, but it's becoming critical at this point, particularly in this area where a lot of the fines and the sediment that's being picked up are valuable topsoil. So essentially, erosion is the removal of the soil. It can be done by wind, rain, water, ice, even gravity. It often is the result of an exposed, unprotected soil. A lot of times it's difficult to stop. It's best to prevent it before it actually happens. Once the erosion occurs, you've got that sediment transfer. Now you're chasing fine particles in moving water. So again, a lot of the activities we can avoid that erosion just by paying attention to revegetation and protecting and redirecting any kind of off-site surface. So just be aware that it is preventable to a degree. If we make those efforts, we can reduce that erosion and reduce the problems that actually go along with it. Today, we're just going to talk about mostly water erosion. So we got main types of water erosion are basically the raindrop, the surface, the rill, and then gully erosion. Typically, erosion essentially is the dislodging of particles. With the raindrop erosion, typically the splash or a raindrop will hit exposed soil. That raindrop travels between 25 and 30 feet per second, so it's got some force behind it. So as it hits that soil surface, it can dislodge small particles within that exposed soil. Once that gets dislodged, it can get picked up by that runoff that carries it away and be transported downstream. So that is basically the beginning part. And this is one of the reasons we want to try to revegetate as soon as possible after exposure, when you expose the soils. once it gets, once that soil is dislodged and you've got that excess runoff that hasn't been able to infiltrate back into the soils, becomes surface runoff. Once that surface starts to move, again, it continues to remove a lot of the spoil particles. The faster it goes, the larger the particles. You can see even in this picture here, you can see a lot of this dislodged material here. The stones, again, the larger the water, the greater the water velocity, the greater the force it has, and the ability for it to dislodge and carry particles downstream. Real erosion is basically once that surface runoff starts to become channeled, develops into rivulets or well-defined channels, and they can be up to several inches thick or deep. This advanced stage of surface erosion essentially is called real erosion. And it can happen on stockpiles as well. It's another reason we want to try to protect those stockpiles. Not only wind can take the material off the top of a stockpile, but also the rain can wash down the sides, create these little real erosion, and carry the smaller particles off. So again, another reason for vegetation. Once it gets a little bit excessive, then you're going to get the gullies. Out in the Ithaca area, they have their gorges. Those are cases of severe erosion. They've created gullies. If they're left unrepaired, they can tend to grow even more. This picture here basically is after a large storm. The shoulder wasn't strong enough wasn't designed properly to shed the water off of it into the ditch adjacent to it. So basically the water channeled, concentrated, and eroded itself and created a gully adjacent to the roadway. So again, just a more severe situation. Some of the erosion issues, well, basically is that moisture flows downhill. It's going to pick up those particles. If the embankments aren't strong enough or the flow is excessive, we're going to get cases where the soil itself starts to disintegrate and starts to, again, erode away and fall and flow downstream. In this case right here, you can see it's potentially inflicting upon this cemetery here. That could be not only unsightly, but dangerous and costly. So again, removing that soil can cause substantial amounts of damage. It's not unusual for rivers to actually erode away backyards, expose septic systems, wash out buildings. So again, being able to control that water flow, that excess flow, if we can capture it, somehow get it back into the ground before it gets downstream and starts flowing quickly, we're going to have a lot more success in protecting ourselves. Again, it can even happen along the side road and ditches and stuff. So again, a lot of times the water will come down a little bit too. We'll get that high intensity rain for a short duration. And it's just more than the soil or the ditches can handle. So there are a lot of issues associated with damage of eroding soil itself. Then you get the sedimentation once that particles in the sediment and the soil pieces start to flow. They get carried downstream. As soon as that water starts to, the velocity of that flow tends to slow down, the particles fall out because it doesn't have that force to push it and carry it at that point. And this is what you'll get. You'll get the water flowing out from ditches up above. You'll even end up with culverts full of pipe. All this adds extra maintenance and labor. So we can try to control that erosion and keep that soil where it belongs. It's going to not only be better for the surface of the soil where it is, but it's going to be better for controlling our maintenance downstream. All right, so some of the obvious things you see is the erosion that comes out. You start to see the soil moving and eroding your lawns or your backyards or cemeteries or whatever it might be. But there's other impacts that happen as well. So as fine particles flow downstream, down through that network of streams in that watershed, that sediment can be discharged into ponds and lakes and a variety of other things. As that sediment flows out of those streams and into the lakes, essentially what happens is that sediment, once it slows, the particles drop out. And as they drop out, those sediment particles land on top of the vegetation. Once it lands on the vegetation, and covers them up, there's no more, it reduces the ability for those plants to actually do their photosynthesis process and release oxygen within the water. So as that sediment lands on those plants, you're going to have a decrease in the amount of dissolved oxygen, which can result in a decrease in the ability for the aquatic environment to survive. Can also cover up, can also land onto small aquatic animals, which can cause them to smother or suffocate. And it also delivers a variety of different pollutants that can be not only harmful to the aquatic environment, but to people as well. So we need to be aware of what we're doing here. Additional issues, aside from the sediment that's being carried down, with that sediment, it carries a variety of different things. There's debris or gross solids, which include trash, leaves, litter, organic debris, which all can result in human illnesses when they collect and they start to enter into ponds or swimming areas or various places where humans interact. There's also chemicals, which include nutrients, which can cause algae blooms. There's heavy metals, organic compounds, hydrocarbons associated with the fuels that get picked up and carried across the surface. They can result in cancer, they can cause cancer and birth defects, not only in humans, but in aquatic life as well. Then there's chlorides. Chlorides, essentially salts, can impact the survival of microinvertebrates and freshwater fish. So ultimately, the water quality of these receiving waters can be drastically impacted and cause the loss of life within that water body itself, and some of the trash that can be hauled with it. Some factors that influence erosion. We've got soil erodibility, and we'll talk about these, vegetative cover, topography, climate, and then the season. Soil erodibility basically is the vulnerability of the soil to erosion. It includes soil structure, texture, and the percentage of organic material. Most erodible soils generally contain high proportions of silt and very fine sand, and those smaller particles that can be picked up and moved easily. The presence of clay, except of course dispersive clay, but the clays organic tend to decrease that soil erodibility. Clays are sticky and tend to bind the soils together. And organic matter helps maintain and stabilize the soil structure through aggregates and interlocking of the soil itself. And this is basically a table out of the new blue book telling the different types of soil erodibility for different types of soils and the slopes associated with them. As you can see, there's you got the gravelly, again, they're a little bit larger, low percentage of fines. So you get the low, and medium as far as erosive potential. But as you get into the finer material, that potential increases substantially as the slope increases. So just to be aware of the type of material that you have is really going to impact how easily that soil is erodible, is going to erode. The vegetative cover, it protects the soil from those erosive forces, particularly the raindrop impact and runoff scour. The top growth essentially shields that surface soil from raindrop impact, while the root mass holds those soil particles in place. The grass can also serve as a buffer strip that can help filter out a lot of that sediment and a lot of the contaminants that are being carried with that sediment within the surface runoff. Grass can also slow the velocity of that runoff and help maintain that infiltration capacity with the soil. As the roots go in, so does the moisture can follow those roots into the soil. So the establishment and maintenance of vegetation are important, are probably the most important factors in minimizing erosion during development. So if you can keep that vegetation on here, it's going to go a lot. It's going to do a lot as far as preventing that soil from being relocated. Topography or grades, essentially the slopes, the slope length, the steepness can greatly influence both the velocity and the volume of the surface water that's being controlled. The longer slopes can deliver a lot more water to the base of a slope, and the steeper slopes can increase that runoff velocity. When you get a increase in volume of water, you can have problems at the bottom because of just sheer volumes going through there. If this system's not designed to carry that weight, then you're gonna have flooding, erosion on the tops where it's flowing where it's not supposed to be. And as well as steep slopes. Once that velocity kicks up and goes extremely fast, again, you've got that the force of the flow of the water that's going to be increase its ability to dislodge any kind of smaller soil particles and carry it down line. Both conditions can enhance the potential for erosion to occur, which is pretty obvious, I suppose. Climate or otherwise weather, basically the erosion can affect the erosion potential. Rainfall characteristics directly influence the amount of runoff that's generated. And these include frequency, how often frequency, intensity, and duration. As the frequency increases, it decreases the chance for runoff infiltration to occur between storms, particularly if that soil has already become saturated, then that surface water is just going to take to the hills, so to speak, downhill. And that's something we experienced with the Irene and Lee. The first storm came through, filled all the ponds, filled all the capacity of storage, saturated the soils, and 2 weeks later, the next storm came through. There wasn't really much that runoff could do but go downhill, downstream, which it resulted in substantial amounts of flooding. As the intensity of the rainfall have been increasing, you get to shorter durations, you might get 5 minutes, but 5 inches of rain in 5 minutes is going to cause substantial amounts of problems, because the rainfall is going to exceed the ability of the soil to actually absorb a lot of that moisture. Seasons as well, season variations of temperature and rainfall can define different periods of high erosion during the year. In the spring, there's a high erosion potential because essentially as that top surface soil thaws and the ground beneath remains frozen, as that surface thaws and melts and starts to flow, the top layer above that, above the frozen layer, is actually going to become more mobile. So again, there's a potential for that as well. A low intensity rainfall may cause substantial erosion because the frozen soil below is not allowing it to infiltrate in. In the summer months, the erosion potential increases due to more frequent and intense rainfalls. So as we get these storms in the summertime that come in short doses but large volumes, again, it exceeds the ability of the soil to take in that infiltration ability. So I guess we have the first question here. We're going to try to stick questions in between here as we go. Question: moving sediment in stormwater does not is the key there. Stabilize streams, carry pollutants, impact aquatic life, or promote growth in harmful algae blooms. Are we getting selections here, Amanda?
Yes, people are answering. I'll wait for our magic number of 75%.
All right.
We're almost there.
Yeah, the key word there was not. Stabilizing does not stabilize stream banks. Moving sediment does carry pollutants. It does impact the aquatic life. And it does promote the growth of harmful algae blooms. And we'll touch on a little bit more on that as we go. But so yeah, moving sediment does not stabilize stream banks. All right, so we'll move on to the next one. If I can get it to work again. Question 2. What concerns are there for nutrients carried by stormwater and sediment? First one, nutrients are harmless. Second one, nutrients keep soil stabilized. Third one, nutrients cause excessive and rapid growth of aquatic vegetation, causing harmful algae blooms. Or 4, nutrients are healthy and for aquatic life.
Answers are rolling in. We got about 5% more to go.
All righty. And the one that everybody got, the 92% nutrients cause excessive and rapid growth of aquatic, whatever it was, or excessive and rapid growth of aquatic vegetation causing harmful algae blooms. Nutrients are healthy for aquatic life. Not necessarily. They tend to, at least phosphorus tends to fertilize the vegetation. Unfortunately, a lot of that is algae that gets fertilized the quickest and the fastest, which is where we get the algae blooms. Nutrients keep soil stabilized only by promoting growth in vegetation, but not within the stormwater. And nutrients aren't harmless for the most part because of what they can do. The answer was number 3. All right, we'll just keep moving here. We'll get into ditches. Ditches are an integral part of the watershed and can be critical for the safety and longevity of the highway itself. They serve to convey surface water, typically away from or through an area safely with minimal impacts. Roadway ditches also collect surface water from the base of the road or surrounding land and can divert water to and from the highway. Most often they carry the surface runoff to natural streams. Ditches are often used by surrounding landowners to carry flow of the water away from their fields. Basically, field tiles that collect that subsurface soil water, again, which reduces potential for it to go back into the soil. But again, they want to dry out that soil so they can actually use the farmland. But a lot of that's diverted into the local ditches. A properly managed ditch is typically relatively shallow and only drains a small area. In many cases, the ditches carry the additional flow, again, from the properties adjacent to it. And if they're not properly designed to maintain, they can result in additional maintenance and untimely costs as the damage and stuff happens. So again, for any kind of ditch, but particularly along the roads, maintenance is critical for both the highway and the environment. There's several types of ditches we've got. We've got roadside ditches, which collect the water from the surface, from the pavement, and carries it parallel to the road. And it channels it to either a channel or a culvert, where the surface can be taken away from the road. It also intersects subsurface water before it gets or intercepts surface water from the fields and adjacent lawns or wherever it might be, before it gets to the surface. There's also diversion ditches. They can run parallel to the highway, but they don't have to be. They can divert water before it gets to a road or a slope or any other feature. They differ from road ditches in 2 ways, is that they don't collect water from runoff from the roadway. And typically they're there only for a diversion. So again, both of these types of ditches can lower the water table because they're, again, a little bit deeper than the surface. So as that surface water just gets into the soil, it can collect a lot of that as well. Then this here is the first one here is just a roadside ditch. Again, if you can keep it vegetated, it's going to be a lot easier to maintain. It's going to be a lot safer, and it's going to look pretty good. In this case, here's a diversion ditch that was put in around a new hotel to keep the water flow from coming from the backwoods and down into the building itself. So they installed a diversion ditch. They've stabilized it with erosion control blankets to slopes, and again, just trying to protect that soil to keep it from moving and relocating that water, diverting that water to somewhere else. Highway drainage basically consists of the ditches alongside of the road, the surface of the road, and then again the both sides of the road here. So you can see this dotted line typically will represent the subsurface water flow within it. In this case, you can see where the subsurface flow is being picked up by the ditch. Again, you can pick up not only from the surface, but you can also pick up subsurface, and that's going to impact how that flow and basically the volume within that ditch itself. But there's also subsurface drains that can be used to, again, with the intent of protecting the soil below this road, protecting the road itself, keeping that soil dry. And you want to lower that, and that's going to decrease your potential for frost and soft soils and a variety of other things. But again, you can see that these, not only the ditches, but these subsurface drains can lower that water table within it, as well as collect from the surface runoff. Here's another sketch basically of streams and road ditches and drainage basins. As you can see here, basically the road surface and typically can cover up to 1% of a watershed surface area. And then the drainage basins collect another 22% within that watershed. And this is kind of just an illustration that kind of show the red lines are road ditches that have, you can see where the watershed they're actually collecting. That yellow area is those drainage basins for each of these ditches. Blue lines are streams, and you can see where they're discharging, the ditches discharge into those streams. And it kind of works its way down as it goes. So it's just kind of a way of illustrating how ditches kind of collect a lot of that surface water and subsurface water within that watershed, and how it impacts the total flow within that watershed itself. The pollutant transfer, as we mentioned that a little bit earlier, ditches, these roadside ditches can carry a lot of variety of types of sediment along with them. They can carry a bunch of times of pollutants. I just mentioned the heavy metals, the chlorides, the nutrients, particularly the phosphorus. Phosphorus will influence the growth in fresh water as far as the algae blooms. So one of those things we need to keep an eye on. That's directly related to fertilization and waste, controlling waste discharges. So again, ditches can transfer that pollutant further downstream, and they're a direct conduit too. If they're not controlled or built properly, they can substantially impact that environment that it's leading to. Safety is another issue with ditches. When a ditch is too deep, it can become a safety hazard. In this case, you can see where the mailman did. Basically, went to pull over and lost himself in the weeds, apparently. But it can be dangerous if you're moving at any kind of rate of speed and you get stuck in there. You could easily get substantially hurt. Something that deep may actually need a guide rail. Typically, ditches don't need to be that deep. Making them deeper doesn't help. If you've got a culvert, driveway culvert within your ditch, that's going to be your limiting factor in that ditch. That's going to control your flow. So if you've got a 12-inch culvert and a 4-foot ditch, that ditch is more of a hazard than a value. So just to be aware, the deeper the ditch does not improve your flow within your ditch itself. Several types and shapes of ditches. You got the U shape, you got a V shape, the trapezoidal shape, and then there's always the filled shape. We'll talk about these. The U shape typically is done by a grade awl, where you scoop out the back and you pull it up and take that extra sediment within there. It's more efficient hydraulically. It's a good shape for erosion control, and it can be built it can be maintained and built pretty easily with an excavating machine. A lot of times the problem with this is that when they're digging out those ditches with those things, they actually pull that bucket toward the road, and they start to erode away the embankment here, which makes for a steep shoulder and causes, again, results in not only erosion, but a safety hazard. So again, there's different ways you can do it. If you dig from the back, you can take that back slope out, and then you can cuff this off and kind of give it a potential, give it so that moisture runs into the ditch and flows. You got the V ditch. This one's fairly easy to construct. You can do it with a grader. However, the center of these ditches, because they are a V, you've got this center point here, tends to concentrate the flow, and as that flow concentrates, it tends, the speed of it tends to accelerate, and then you get the increased potential of erosion. Again, it's always good to try to stabilize these. You can, and they've made an effort here of stabilizing with some hay and straw, but more needs to be done. That's inadequate. You get the trapezoidal shape. This is hydraulically, this is the most efficient because you're taking that flow and spreading it out over a wider area. You don't have those concentrations. And typically you use them for a ditch that's actually carrying a large volume of large amount of water. And basically, as you keep it spread out, it's the velocity of that flow is going to be decreased. Part of the problem with this is we just don't have the right of way in a lot of the local roads to build these kind of things. So that's an issue. They can be difficult to construct. But if you do have a situation where you need to construct something like this, reach out for help. Soil and water conservation districts are here for a reason. They've got a lot of knowledge on what needs to be done. They can direct you in the right vegetation that needs to be planted. Again, the resources are there. Don't hesitate to use them. That's what they're for. And sometimes ditches are filled with large stone to make them safer for traffic. When you've got a deep ditch that's got a steep slope on it, maybe you want to bring that elevation up. Bring it up here so it's not as damaging to vehicles. And so basically, simply what they do basically is put in a culvert, typically in the roadside. They'll put some sort of fabric, some erosion control blanket, get your perforated pipe or your solid pipe in there. Typically a perforated pipe so you can collect the flow that's coming in. And then you backfill it with stone. As you can see, here's an example of it. They did the change from the ditch to a subsurface pipe. So again, it's just another means of doing it. But again, another way of protecting if you've got a safety issue with your deep ditches or erosion problems, you can actually channel them and collect it in pipes and redirect them. So as you mentioned, most ditches have most of the capacity that they need. Typically, the need for a ditch is pretty small. Again, when you start getting other things feeding into it, then it's going to be a little bit different. Then you should actually reach out to get some help, whether it's the soil and water or an engineer, or even contact us. We can do some help for you. But typically, her historical perspective is enough to determine if the ditch is large enough. The flows are normal, and that's a rule of thumb. If it's doing well, then again, your culverts are going to be your limiting factor. But ideally, as far as the depth goes, it only needs to be ideally, this is your clean, free-flowing subbase in your roadway. Any moisture that comes up or through it, ideally is going to drain out here. So typically about a 1 foot depth difference between the bottom of your free-flowing base in your roadway and the bottom of your ditch to keep that ditch flowing. Again, your capacity is basically going to be limited by the culvert pipes that you have in there. So if you've got 12-inch or 18-inch, that's going to be your capacity of that ditch. So an 8 foot wide ditch, the 4 foot deep, 8 foot by 4 foot deep ditch, going into an 18-inch pipe doesn't make much sense. Again, side slopes. You want those side slopes on those ditches to be somewhat traversable if you can. Someone gets off the road, it'd be nice if they could just work their way back out instead of just ramming right into the hole. Flat as possible is ideal. Again, we're limited on right-of-ways on a lot of the private roads or the smaller local roads. Slopes steeper than the 1 on 2, vertical, horizontal, tend to be unstable and may need a guide rail to protect them from any kind of damage or errant vehicles that are going through there. Ideally, a slope 1 on 3 is considered good. And for more information on this, you could reach out to our drainage manual, chapter 9. It's got more on the slopes themselves, but again, if we can keep them flatter, they're going to be a lot safer and they're going to be a lot easier to maintain. If they're flatter too, you can mow them, and that's going to help as far as maintenance goes. Here's a case for the state over by Cornell. This is Cornell campus on the opposite side of the road, and some of the orchards on this side over here on the left side. But they came through and they cleaned their ditch. So as I mentioned, it's greater than 1 on 2, so you can see this ditch is pretty steep. It could be potentially unstable. So we came back a week or so later after they had done this, and you could see that slope is unstable. As it started to dry, that soil started to slough in here. There's actually a cross culvert right here that goes across. So you can see on here, it's right by this tree. There's a marker right there for the culvert. Again, that culvert is right here that drains through. Because it started to slough in and carry a lot of the sediment downstream and started creating problems, they came in and actually filled it. They put a subsurface pipe in here, perforated pipe, covered it with gravel, a little bit of fabric, and then put some topsoil on it. And now it's easily managed. It's not dangerous. They can mow it. A lot of benefits that they've obtained from doing a lot of that. So when it comes to cleaning or reshaping your ditches, it's kind of talks a little bit about what is your ditch here. You want to kind of clean a little bit. As I mentioned, if you're in some of those buckets and you come and you pull it toward the road, you're going to take that ditch and it's going to become steeper. And again, not only more dangerous, but it's going to decrease the stability of that embankment to support the road and the stream, the flow in it as itself. And you're also making it deeper by pulling it. Ideally, if you want to clean those ditches, you can clean from the out, keep the same four slopes. So maintain that slope from the roadway. And the flow is just going to come off the shoulder and then into there. Your free flowing base. You don't really want to mess with that. But if you want to clean it, maintain the same depth, you take it from the backside. And that'll reduce a lot of problems later on. We've got a few pictures here. You can see that they kind of cleaned up here, left a little bit of vegetation across here. But again, they didn't do any effort to stabilize it. It's going to be actually difficult to get any kind of vegetation in there now because of the type of soil and a lot of the fines are gone. But again, you can see they've cut that slope. The slope could potentially become a little bit unstable. So again, just being aware. And when you're doing these things, be aware of the culverts. That culvert just reduces capacity by probably 50% just by crushing that end on it. Now you don't have the proper flow through it. It's going to back up and it's going to cause problems elsewhere. There's another case. They've actually did a nice job. They've cleaned it from the backside. They've got a nice U shape to it. They've got a nice shoulder here to serve as a filter strip. Unfortunately, they didn't seed it. They didn't stabilize. They didn't try to get some vegetation in there. When it comes to this vegetation, don't be afraid to reach out to the soil. Most of the soil and water conservation districts in New York State have their own hydroseeder. You do have one in your county. Reach out to them before you start doing your ditching. Contact them. Try to coordinate your schedules. And once you get done shaping this thing and getting it in good shape, have them come in and hydroseed it. They'll recommend the type of seed that's best for the area and the soil. You would pay for the seed, but they would come out and take care of the stabilization with their equipment. So it's a service that's out there. Don't overlook it. Again, the idea is we're just trying to protect the environment and stabilize our roads as well. Diversion ditches, again, typically diversion is basically a conveyance channel. You want to divert water off site or away from a construction site. A lot of times they can be temporary. They can be rock lined, they can be stone. If they're rock lined, the stone is going to be based on the flow, or you can line them with a fabric, some sort of fabric. And again, typically temporary, comes in a variety of different things. They made an attempt here to stabilize it with some soil, but it looks like it dried out before it was able to stabilize. Another job site where they're diverting water and trying to collect it and get it away from the main spot where they're working. Keep that area dry, minimize any kind of erosion off that site. And this one I pointed out before. Again, they built a hotel down below. This is their sedimentation pond for the parking lot. But they've got this all stabilized here, and they've got this diversion trench that goes up and around the whole facility. It collects that runoff from the upper wooded area. So again, there's the ditches have different purposes and uses, but again, controlling and collecting that water and preventing erosion is ideally the ultimate. So storm sewers, again, typically these are subsurface collection systems designed to collect and remove surface runoff. Used to be common place in a lot of the residential developments. And they're in urban areas. And typically the most visual thing you might have as far as that are these inlets, drainage inlets. As with ditches, again, the intent is to remove that surface water. As that water runoff flows across those impervious surfaces, again, it collects a lot of those nasty pollutants, the hydrocarbons, the debris, the sediment, the chemicals. And typically they'll empty directly into these drainage systems. If they're not maintained, it becomes a direct conduit to the discharge into any kind of local water body itself. Limiting factor in a lot of these can be the grates. You've got the bicycle safe grates, you've got heel safe grates, depending on if you're in an urban area or whatever it is. Intake of those grates is going to vary differently depending on the type of openings. The more metal you have, the smaller the open area, the lower the ability of that structure to take that flow in. A lot of the manufacturers have flow designs go in there. Typically, they'll have a 4 or 5 inches head over top of those culverts for maximum intake for those flows. But if you're in a roadway, that 4 or 5 inches might not be the best thing to have. Might become a hazard. So be aware where you're putting these things and what the flow is going to be, the type of grate you're going to have. It's all going to make a difference on not only safety but inlet intake. All right. Catch basins typically are common in some of the issues related with storm systems are similar to ones with multiple pipe culverts. And if they're undersized or they don't have proper cover, they can have the potential for floating, particularly plastic pipes. If you don't have a lot of ballast on top of it, air gets trapped in there, it's going to rise, it's going to float. You've got the pipe separation issue. Once they start to separate, you're going to start to lose that support around it, and you're going to start to have problems from the surface down. There's also sediment buildup. Typically, a lot of these structures have a sump built into them. And ideally, this as the water comes in, any kind of sediment's going to get in there, the flow is going to slow down, sediment's going to fall out. Occasionally, they'll have an inlet that's turned down. Idea behind that is any kind of fluids or oils that float on top, you'll be drawing from below it. You won't be drawing out of that. So different factors that are items that are inside of these things. Ideally, once those solids reach the 1/3 level of that storage capacity in that basin itself, should be cleaned. Once it gets higher, as that flow comes in, it churns it up and causes that sediment to just get resuspended and then moved right out. So again, regular maintenance on these things is important as well. Regular inspection is important not only for the basins. Some of these older basins and manholes are built up with brick. Over time, the brick starts to degrade, fall apart essentially. And the grates will start to not only become crooked, but they can become unsafe as well. So inspection on those as well. Inspection on your basins, connections around the pipes, the connection of pipes, running a camera through your system every once in a while isn't a bad idea. And one other thing too is if you're putting in new storm sewer or sanitary pipes, you need to have a minimum separation of 10 feet from any potable water system. If it's necessary for them to cross, typically an 18-inch separation is minimum. And then you need to encase both pipes in each direction, 10 feet. So at that crossing point, each pipe needs about 10 feet of concrete encasement around there. Again, you want to minimize any kind of cross connection or contact with the potable water system. And if you've got a gravity flow system like you would in stormwater, unless you've got a pump, but if you're planning on a gravity system, you're going to have to be aware of where those pipes are. Don't design a pipe to go through a water pipe. Just be aware of what you're doing and double check as you're going. Discharge points. Unfortunately, as that runoff runs over those impervious surfaces, as I mentioned, you're going to pick up all those hydrocarbons and sediment and chemicals. And then they direct a lot more often the older systems directly into the river. So again, be aware of what's going on there. If you can collect that sediment within the basement and keep the catch basin itself in the sump of that basin and keep them clean, you're going to reduce any kind of sediment flow that's going to carry some of the debris with you. Again, these flows here at this point, when they discharge here, are highly concentrated in the pollutants that they're carrying. And then they discharge again, become harmful. So we need to be aware of that in multiple cases. Again, it's a lot of these are done historically. This one's actually the village of Nyack, where their system discharges out into the Hudson River. This one here is central New York that's collected from a small village that collects and discharges into one of the rivers there. So again, discharge points are important. You need to be aware of where they're going and what's happening. So what can we do? Well, ideally, as per the DEC, preventing the erosion is your first line of defense. If you can prevent that sediment from being dislodged, you're going to have a lot more success on reducing that erosion. Once that sediment gets moving, now you've got to battle with the sediment control. You got to try to collect it, slow it down, try to clean it, maintain it. A lot more maintenance once that sediment starts getting moving. So again, if we can prevent that erosion in the long run, we're going to be a lot better off as far as everything else later on. When it comes to ditches, again, be aware of what's happening. The ditch lining, erodibility is how vulnerable it is to erode. So obviously, you've got high erodibility. Low here, you've got the earth bottom, and the mowed grass, unmowed stone. So you can see as they become a little bit more heavier and a little bit more robust. As far as retardants, basically resistance to that flow. Concrete, as you would expect, is smooth. It's going to have minimal retardants. Fabric as well, if it's adhered to the soil properly. Even the bare earth is going to have low retardants. But once you start to get the vegetation or the stone bottom in there, that's going to increase resistance and slow that flow down a little bit. Slowing the flow down is going to be important. But again, having vegetation there is going to keep it stabilized as well. So essentially, when it comes to vegetation, again, vegetation include grass, brush, trees, can be all planted to kind of reduce that erosion potential through there. As I mentioned, Soil and Water can recommend different types of vegetation that are best for your area and your soils. And reach out. They're there to help. And the general rule is basically, if you can use vegetation, do it, because it's going to be a lot easier to maintain. It's going to be a lot cheaper to install, and it's more pleasing to the eye. Again, with this, you're going to have that vegetation. It's going to filter out some of the sediments. It's going to promote infiltration back into the ground. There's a lot of benefits to it. Some cases, the flow is a little higher than you can handle. In this case, you may want to line it with some sort of aggregate. In this case, they've used large riprap. Here, it comes off of the road edge and into it. Again, you can tell this is a little bit more like a trapezoidal. So likely that they had quite a bit of flow coming through here. Again, another trapezoidal shaped structure here. This was actually taken after the Irene and Lee. This is a repair that they did. This whole section here had been eroded out, causing a lot of problems at the bottom of the hill. So this was kind of their repair. They've gotten this slope a little bit better. It's starting to grow vegetation. It looks good now. I've been by it, but earlier days it wasn't. There was still some rilling here. But again, the idea is to kind of control the erosion within that ditch once you've captured that flow and you've got it moving. So you mentioned in the retardants, low retardants with the concrete. Again, it's got resistance to erosion, but again, maintenance is required. Once these things start to separate, the water can get below it and cause issues at that point as well. Everything needs maintenance. Nothing's ever a one and done. Other options, again, for discharges, possibly you could use some of these heavy fabrics. First time I saw these, they were used as flooring in pig barns of all things. But they've used them for various types of livestock, but it also serves as a good a matting for an outlet at a culvert head. As I mentioned before, those ditches typically they have a lot of volume. Once you stuff it into a little pipe, the only way you can get that amount of volume through it is just to accelerate the speed. So as that velocity comes out of here at high velocity, you want to protect that somehow. You want to kind of protect that outlet to keep it from eroding out. Again, you can use erosion control blankets. If you're installing these, you want to start at the low end and work uphill. That'll prevent the flow downhill from getting underneath and tearing it up. And again, you'll want to pin them down. You want to keep them tight. And it, again, topsoil underneath it, put your seeding down underneath it and allow that stuff to grow up within it. And over time, it'll become a vegetated channel as well. In some cases, the riprap may not be large enough. This came across this in Washington County. Essentially, the slope was too great. It was actually causing a lot of this aggregate to be washed downhill. So they ended up coming through with a slurry and help stabilize that stone. It actually works out pretty well. They can get in here with a pressure washer and wash out any kind of built up sediment. One thing to notice with this is with any kind of loose concrete, do it in dry weather if you're gonna. You do not want this, the chlorides and the materials within that concrete into any kind of water body. Check dams, basically a means of slowing down the velocity as it's going through. If you can slow that velocity down, you're going to reduce that potential for erosion. In this case, you've got permanent ones. This comes out of a stream. You'll notice it built up. And you want to kind of try to concentrate in the flow with all these check dams if you can, keep them to the center. But again, it allows basically as that water falls, you're going to dissipate energy. Instead of it accelerating, it's going to drop and fall. The splash will create a dispersion of energy, and then the flow will maintain substantially slower. One of the important things too is creating a subbase here, a splash pad. As this washes over, you don't want it to erode out and cause this whole thing to fail. But again, it can be temporary, they can be permanent. Variety of different methods that they've got out there. It can be stone, sandbags, wood, concrete, gabions. And the idea basically is to slow that discharge rate as it flows through. This is a little different case that I came across. They had problems with sediment washing through the pipe. So they put this little weir structure in here, check dam weir structure. They've got a low flow orifice here that allows the normal flow to go through. But when the higher flows come through, they tend to carry a lot of sediment. So what they ended up doing was putting this here. They capture that sediment before it would get down into the lawns and the neighborhoods down below. And then after the rain, they come back. This is basically an intersection of a road here. They'd be able to just scoop it right out and take that sediment and open it back up. So different things that can be done. But check dams, again, the idea behind these are to slow that velocity. It does by slowing it, it'll help filter out some of the sediment in there. Ideally, again, you want to stabilize that surrounding areas with vegetation. But again, the check dams, the idea is basically to slow that velocity down, minimize that potential for erosion. And it can be done with these koi logs as well. They've got a fabric down below. Again, this is typically a temporary method. But again, you can capture that and allow that flow to flow down through here. By putting these through. Silt fence will not work in this situation, but this material here is substantially more porous and will actually help filter out a lot of the material itself, a lot of the sediment stuff just by the nature of its design. Again, do not use silt fence in a moving channel of water. Cleaning ditches typically just involves the removal of the sediment within the vegetation in the bottom of the ditch. You want to remove very little material if you can. You don't want to reshape it. You don't want to redig it. You just want to keep that flow going. And after you've done this, you should actually check the ditch, make sure that it's stable. And as you go, spread some seed, annual perennial grass seed, and then walk it in. Typically, a cleaning of the ditch doesn't involve changing the width or the depth of the ditch. Again, as we mentioned, if the ditch is too deep, it can be hazardous. Reshaping is another process. Basically, if your ditch has become a little bit errant and hasn't been maintained in a while, you can reshape using, typically it involves removing larger amounts of material, widening or deepening the ditch. Can be referred to as cleaning it, but again, the same issue comes along. You need to come down through here, make sure it's clean, make sure it flows properly. Ideally, some general tips as you start at the bottom and work up. Maybe against traffic sometimes, but again, you can get that slope. You work down, you can end up too deep and end up with a point where you've got a flat spot or a collection of water, which can be a mosquito nest. Another thing is to have your erosion control material there. If you're going to put erosion control blankets down, have it there. If you're going to seed it, have it there ready to go. Seed after every day. I get that when that soil is still moist and that seed can germinate in there, or work with your soil and water. See if you can get their hydro seeder over there within a day or so. And you want to do that before the soil dries up and before the rain, because it's all going to cause problems later on. All right, so we got another question. Guess we're getting close to the run here. When ditching, which is not a best practice. Remove only what needs to be removed. Work uphill to avoid flat spots. Reseed every day to promote vegetation, or the last one, dig as deep as possible to increase ditch capacity. Again, which is not a best practice.
Votes are coming in. I'll give you guys a few more seconds.
And the last one is correct. It is always good to reseed every day after you've done any kind of disturbance. If you can reseed that, you're going to get that vegetation growth. Remove only what needs to be removed. Again, you're trying to remove the sediment. Ideally, those ditches are in shape, already there. You don't want to over dig. You don't want to, expose too much or cause any kind of slope values. So letter D is the correct answer for that. All right, we'll move on to the next one. Question number 4, which is not, again, not a means of minimizing erosion. Number 1 is check dams, planting vegetation is the second one. We're using rain gardens is the third, and exposing soil for extended periods of time. Yeah, the last one is the right answer. Check dams will slow that velocity down. So essentially that'll minimize erosion by reducing that velocity, which reduces the potential for erosion. In planting vegetation, it erodes again. It's going to help filter it out, help reduce some of its velocity, again, increasing its resistance as that water flows. All right, so we got a few more slides here. We'll just go through. Again, I can't stress the use of the hydro seeders that are, if you have them available, schedule it, work with the soil and water, and make sure they've got the time to do it, and doing it at the same time that you're cleaning your ditches. Stabilize that soil. It's going to reduce that sedimentation. It's going to reduce the erosion potential as that ditch goes through. You can get that vegetation in there. It's going to help stabilize everything. That'll help reduce any of the issues that you're going to find within that stream and wherever that stream goes to. Check dams. Again, check dams are used to try to slow that velocity down. Typically, they're how many you need, it basically depends on the slope. The bottom of the toe, the next one up, the bottom would be equal to this. So whatever the slope would be, if it's a really steep slope, the top of this one is going to match the bottom of the one above it. So again, the spacing is going to depend on the slope itself, not any given number of feet or however it works. It's just going to depend on the slope, and that'll be your frequency of how many you need. And again, you're trying to slow that velocity down. If you let it run too fast and too hard, it's going to get a lot of momentum going. It's going to cause problems. And your ditches, they don't need to be as deep as they often end up being. If you can just keep them clean, in this case, maybe they built the road up. Maybe this is why it's a little bit lower. But again, this could be a potential hazard. Keeping it mowed is going to help identify some of the hazards that are there. And if it becomes a potential problem, maybe you want to put some delineators up just to let people know that you're at the edge of the road. It's getting close. But again, deeper ditches don't make better flow. They create hazards and liability. And in rain gardens, low areas, if you can capture that flow and let it set it back into the ground, that's going to be ideal. Particularly in larger parking lots and areas like that, where you don't want to necessarily collect that water and send it into the local ditch. You can capture that, get it so it's sediment settles, it'll slow down, the sediment will drop. and allow that moisture to infiltrate back into the ground. That's what we're looking for, is that water back into the ground, into the aquifer, recharge the wells, recharge the streams, recharge the snow, the ponds and the lakes. And then be aware of what you're actually doing. Digging a ditch for the sake of digging a ditch doesn't necessarily improve what's going on. This case right here, they're probably not making a difference as far as the flow, improving the flow. It looks like it's fairly flat. Looks like they're making work. Now they've got an erosion problem. The homeowner is probably furious because they can't mow it anymore. It just leads to a lot of problems. Be aware of what you're doing. If you can have a vegetated, nice, smooth swale like that, and allow it to flow and infiltrate in, you're a lot better off. And that'll do it today. Did we get any questions, or are we all set?
We do have one question. You discuss using hydroseeding in recently cleared ditches for restabilization. Normally, hydroseed is discouraged in areas of concentrated flow. It washes out easily. A better application would be along upper slopes than in the ditch bottom. Could you discuss recommendations / success stories for stabilizing the flow line of ditches?
Yeah, that's an excellent point. Yeah, when you spray that in there, typically if it hasn't had the opportunity of stabilizing and growing, it's just going to be washed away. The center line, as far as best practices, you might want to try to use a fabric or widen the base of the ditch itself to try to slow that velocity. Ideally, you don't necessarily want to use riprap in a situation if you can avoid it, because it's hard to maintain. Sediment builds up in it. It's hard to keep clean. But if you can get, maybe some sort of erosion control blankets in that ditch, vegetate and allow that vegetation to grow up through it, you're going to have a lot more success. Spraying that hydroseeding definitely, as far as even dropping seed and walking them in that flow line, it's potentially a place for failure of that. It's going to carry a lot of that sediment seed away. So yeah, if you've got a situation where it's a regular flow, you might want to use some sort of erosion control blanket in there to try to stabilize it. Again, working from the bottom up, so when you get those laps, the laps are flowing over top of the next flow and not pulling up. Not sure if that answered the question, but there's a lot to be said about that center flow line. Yeah, it can cause problems.
And we got one more quick one. Can you use an existing stone wall as erosion sediment control along entire property line?
An existing stone wall, I'm assuming a historical stone wall. You need to be careful if you're going to do that. Part of the problem is you may undermine that stone wall itself. A lot of those old historical stone walls are just basically, they're moving stones out of fields and they're stacking them along the road lines or the fence lines. They aren't necessarily built. If they start to undermine, you're going to have a failure. If it's on a private property, you might have some unhappy residents there. If you're going to do that, maybe try to get the flow line a little bit away from that wall. Maybe try to stabilize against the base of that wall somehow to try to prevent that erosion. Maybe some fabric or even riprap along the base of that wall to try to protect it, or both. Again, you don't want that any kind of those historic walls to start to undermine and fall in. If that answers you.
It looks like our last question. Thank you, Jeff. Thank you guys for joining us on our last foundational webinar for the spring season. We'll see you all in the summer.
Yeah, I'll be starting out with asset management in mid-June.
Perfect. Thanks, Jeff.
All right, thanks. Thanks, everyone.